Greetings everyone, and today I will be presenting to all of you the mathematics integration competency. This question I obtained from the pretest form, so without wasting time, let's jump to the questions. So the first one, you got antiderivative of x to the power n. So for this one, what you want to do first is to make it like this. And for this kind of integration, you must add up the power. So you will get x to the power n plus 1. You also need to divide this expression by its own added power, n plus 1. Since this is integration, so keep in mind that you need to add up the constant plus c. So this is the answer for antiderivative of x to the power n. So moving on to the next, what is the antiderivative of 1 over x? So you do the same thing, 1 over x, integrand dx. So this one is quite straightforward. So if you recall back the differentiation part, you will know that ln x, if you integrate it, you will get 1 over x. Yes, you can actually reverse the order by writing it like this: ln x plus c. However, this x can be either positive or negative. It is known that any negative numbers, if you ln them, you will get undefined. So, since we want to get rid of this negative, we should add modulus into the x. Should add modulus x over here to make the integration complete. So this is the antiderivative of 1 over x. Next one, what is the antiderivative of 2x cubed? You write down the derivative and the integrand dx. First, you move out the constant 2 from the integral. You are left with x cubed to the power dx. Now that 2 is out of the integral sign, then all you have to do is just integrate dx cubed. So it is equals to 2 x, you add the power and you divide x to the power by its own added power, 3 plus 1, plus the constant, because this is integration, so you must add the constant as well. So you will get 2x to the power 4 over 4 plus c. You simplify the equation by dividing 2 here and it's going to be x to the power 4 over 2 plus c. That's the antiderivative of 2x cubed. Moving on to the next, you get antiderivative of 4 over 2x minus 1. You write down the derivative first. You should not forget the dx, as this is the integration. Okay? So, if you encounter this kind of expression, so since this one is fractional and the x is actually on the denominator side, what you have to do is check if the denominator one is constant. If it is constant, then surely you can just move 4 outside the integral. So you are left with 1 over 2x minus 1 dx. Now that you have this 1 over something here, now it's a good time for you to recall where if you integrate 1 over any function dx, you will get, excuse me, this is not the right one actually. It should be like this: ax plus b. So you look out for this one. If this one has a coefficient of 1, then it's the same as 1 over x. But since this one has 2 as the coefficient, so you have to put in ax plus b. So if you integrate this, you should get 1 over a ln, modulus ax minus b. So we will try to replicate this one into this one. So you will get 4 you put square bracket here, 1 over 2 ln 2x minus 1. Make sure to write the modulus after you integrate 1 over x, or 1 over its function, plus constant c, and then you multiply 4 with 1 over 2. You will get 2 ln 2x minus 1 plus c. Alright, so moving on to the second last question, I think. So this one is antiderivative of secant square x. So I am pretty sure that most of you will forget what is the antiderivative of trigonometry. But don't worry, if you all tend to forget the antiderivative of trigonometry, you can always refer to its differentiation. So recall back. if you differentiate tangent x, you will get secant square x. Well, for the integration, you basically reverse the operation. So this one is the differentiation part, and this one's going to be the integration part. So you write down the derivatives. Excuse me, there's not enough space here. You have secant square x dx is equals to tangent x plus constant c. So this is the integration of secant square x. And last but not least, the antiderivative of 2 secant square x. So you write down the derivatives first. And first, you take out the constant 2 from the integral part. So secant square dx, excuse me, x dx. After that, you integrate what is inside the integral. So 2, as we did just now, secant square x is actually equals to tangent x plus c. So you put it tangent x plus c. So it's going to be tangent x plus c. Well, I think that's all for the video tuition I got just now. And if you think that if there's anything wrong with my solution here, you can just PM me via WhatsApp or Telegram. It's up to you. And I hope you guys will enjoy this video. Well, peace.